So as I had mentioned, we'll now move on to integration using differentiation. Now before we begin that, let's take an example. Let's say we have been asked to integrate this integral, which is dx by 5 plus 4 cos x whole square. Now, with the knowledge which you have till now, what you will do, or what any person will do, is that he'll start with this. I have just expanded this. After that, what you will be doing is that you will try to convert this into form of tan square x, because we had developed something similar of this form. So if you divide by cos square x, you will get sec square x, 25 sec square x plus 16 plus 20 sec x. What I have done is I have divided numerator and denominator by cos square x. Now you see, you have landed up in a problem, and at least now I can't think of a solution through which I can solve this integral. Now the mistake which I had made here is that, as I had mentioned, for integrals where you have a sin x plus b cos x whole square, in this you can apply this type of approach. That means the approach is dividing by cos square x. But this is a slight different integral. So in this type of integrals, we use integration using differentiation. Now, some common forms in which we'll be using integration using differentiation are dx by a plus b cos x whole square. This was the form which we were discussing. Also, if you have something of the form of dx by a plus b sin x, then also you'll be using integration using differentiation. Also, when we get something of the form of dx by sin x plus a sec x, then also we use integration using differentiation. Now what method we follow in integration using differentiation is as follows. What we do is, we take a term a. Now what a is, when we have an integration of this form, we take a as sin x divided by a plus b cos x, and when our integration is dx by a plus b sin x whole square, we take a as, what should a be? It is cos x by a plus b sin x. Now after we have taken a suitable a, what we do is, we will take the derivative of a. Now it's better if we solve an example and then we see how we use integration using differentiation. So let's take the example of dx divided by 5 plus 4 cos of x whole square. Now in this case, as I had said, I'll take a as sin x divided by 5 plus 4 cos of x. Now again, as I had said, I'll take the derivative. So my dA by dx becomes 5 plus 4 cos of x whole square, and the numerator we have 5 plus 4 cos x. The differentiation of sin x is cos x minus sin of x, and then I'll differentiate this part, so it becomes minus 4 of sin x. Okay, so if I simplify this now, it becomes 5 cos x plus 4 divided by 5 plus 4 cos x whole square. I hope this part is clear. See, 5 multiplied by cos x is 5 cos x, and then we have 4 cos square x, and here I have minus sin x into minus 4 sin x, so it's 4 sin square x. So 4 cos square x plus 4 sin square x becomes 4. So this is what I get. Now what I'll do is, I have this in my denominator, 5 plus 4 cos x whole square. The numerator, I'll write it in this form. What I'm trying to do is that I'm trying to write the numerator in terms of 5 plus 4 cos x. Why I'm doing this will become clear subsequently. So what I have done is, I have written 5 cos x plus 4 in terms of 4 cos x plus 5. Okay. So this is, I have got till here. Now, what does this become? This part and this part are two parts. Okay. The first part becomes 5 by 4 into 1 by 5 plus 4 cos of x, right? Because you have power 1, you have power 2 here, so ultimately you will get this, plus minus 9 by 4, 1 by 5 plus 4 cos x whole square. Okay, 4 minus 25 by 4 is minus 9 by 4, so I get this. So now I am left with solving this. Now what I'll do is integrate this, integrate both sides. So here you will get a, here you will get 5 by 4 integration of 1 plus 5 plus 4 cos x into dx minus 9 by 4 integration of 1 plus 5 by 4 cos of x whole square into dx. Now you see, this is exactly the term which we have to integrate and whose answer we need to find out. So we have got this term. Now let's see what we can do. We can write now 9 by 4 integration of 5 plus 4 cos x whole square. This is equal to 5 by 4 integration of 1 by 5 plus 4 cos x dx minus a. Now we are required to solve this integration. If we are able to solve this integration, then we will get the answer of this integration, right? So, and I hope you know how to solve this integration. What we will do is, we will convert cos x in terms of tan square x by 2. So this becomes dx divided by 5 plus 4 1 minus tan square x by 2 divided by 1 plus tan square x by 2 minus a. What is a? It's sin x divided by 5 plus 4 cos of x, right? Okay. Well, now let's solve this. So let me erase all of this and let's write what we have to solve. We have 9 by 4 integration of dx by 5 plus 4 cos of x whole square, which is equal to 5 by 4 integration of, let's simplify this. So if we simplify this, we'll get 1 plus tan square x by 2 divided by 9 plus tan square x by 2 dx minus, we have sin x by 5 plus 4 cos x. So we are required to solve this integral. Okay. Now let's remove this 9 by 4. So I'll get 5 by 9 here, and I'll get 4 by 9 here. Okay. So this becomes 5 by 9. This I can write it as sec square x by 2, 9 plus tan square x by 2 dx minus 4 by 9 sin x 5 plus 4 cos x. Now you know if I take tan x as t, tan x by 2 as t, so what I'll do is I'll take tan x by 2 as t. So half sec square x by 2 dx becomes dt. So sec square x by 2 dx becomes 2 dt. Integration of 2 dt by 9 plus t square minus this term. Now you see this is a very simple integral. So solution is tan inverse t by 3 minus 4 by 9 sin x 5 plus 4 cos of x. So my answer is 10 by 27 tan inverse. And what is t? T is tan x by 2. Five plus 4 cos of x. So this is my solution. So you see that there are some integrals which can be solved using differentiation. Next we move on to integration of some special irrational algebraic functions.